Today we're going to look at another one of these really cool early integrated circuits from the Eastern Bloc. And this one is called the MAC198 and is a sample and hold amplifier. And how it does that is quite apparent from this block diagram here. So you can see what we have is basically an op-amp. I'll just get a pointer here. We have a buffer op-amp that is connected to a switch here, and this is just some logic that would activate this. And then we have another amplifier, another buffer amplifier, that is connected to the hold capacitor. And you connect an external capacitor here, and basically once you activate this, it buffers the input voltage, sends it through here into the capacitor, and the output amplifier will then buffer this out. So it's just a basic sample and hold amplifier. Very easy, very cool. This is, I think, a little bit later than the very early circuits we looked at in the previous videos. This has quite a few transistors in it compared to something like the MAC198, which only had 3 of them. So here's a basic example of how you'd use that. Differential power coming in here, hold capacitor connected to ground, and input output. And here they use 5-volt logic to activate the sample and hold, but it says somewhere down here or up here somewhere. Oh yeah, this is voltage 7 and 8, maximum 7 volts, and VCC plus minus 18 volt maximum. So what I choose to do is I'm running everything off differential 6 volts. And that seems to work fine, because it gives you a minimum of somewhere here. Can't find it and I can't read what that says, but somewhere around here it should give us a minimum voltage of the differential, the differential input voltage, and it's plus minus 5 volts. So 6 will allow us, plus minus 6 volts will allow us to run everything off the same power supply. And that's the only reason I'm doing it. It would probably work better with more voltage here. They also give us some basic values for C-hold. They say 10 nanofarads, I think that should be. 0.01 microfarad should be 10 nanofarads. I'm using way more in my example circuit, but that's fine. So yeah, I think that's all I have to say about this data sheet. There's another version, the MAB398, and that is not different in a lot of things, but temperature rating is different, and also the voltage rating is a little different, I think. So okay, let's go to the example circuit. And this is what we have. We have our chip in the middle down here. I've got on this potentiometer an adjustable voltage between the positive rail and ground that's fed into in, and it's just a 1 mega ohm pot. We've got our negative rail connected here. We've got a switch connected to the positive voltage, 6 volts, and the SH input, and this is pulled down via a 10k resistor to ground. The LR is connected to ground, and as a hold capacitor I'm using a 1 microfarad film cap. This is relatively low leakage, and that's what's really important. You want something that has as low a leakage current as possible. would probably be better to use a smaller capacitor if you wanted to sample and hold relatively fast, because the internal buffer needs to charge or discharge this every time you sample. So smaller capacitor, probably way better, but I put a smaller one in there initially and it had relatively high leakage, so it wasn't all that stable. Now I put a larger one in that also has lower leakage, and that seemed to help. Okay, if we want to test this, we should hook up a couple meters, and I should zoom out a little bit. There we go. So 1 meter, second meter, and both of the negative terminals here are connected to these little ground hooks down here. This one I'm going to connect to the input, and this one I'm going to connect to the output. So we'll see input here and output here. Okay, all that's left is to hook up power. Negative rail goes here. The positive rail, the ground, goes here. And the positive rail will connect up here. All right, switch the power supply on. And we can see I've got about 2 volts on the input here, and I've got something undefined on the output here. And this should settle down in a minute, I think, because I just switched on the power supply. That's not stable enough yet. But what we can do is push this button. And we're sampling and holding. You can actually see slowly discharging the hold capacitor. And one of the meters will probably switch off in a second. But it's basically holding the value. And if I turn this to, I don't know, some other value, I can sample this again and it will hold this value. This is not ideal. The capacitor I selected is probably not perfect. And also, this switch is not debounced. You'd obviously use debouncing, because what we're probably doing at the moment is we're sampling 27 times and 5 of them incorrectly, and then the last one sort of gets latched in because this switch has bounce. And probably quite a lot of it on it. So yeah, this is basically what you do. And to finish this relatively short video up, quick channel announcement. I think for now this is the last one of the early integrated circuit videos I'm going to do. I'm going to continue making them, I think. But I'm going to sort of interleave them with more project-based videos, which I also really enjoy making. And I think that's what most of my viewers actually subscribe to the channel for. So this has been great fun, and it's not going away. But I'm going to do more project-based stuff the next couple of weeks. And then maybe every once in a while, if I come across an interesting circuit, I'll do one of these early integrated circuit videos. Like about this, which we had this actually in a previous video. This is another clone of the RCA CA 3000 differential amp. But this is a Russian mil-spec copy, and it's really cool. I'm going to do something with this. I've got some other mystery Russian chips for which I have to find a datasheet still. These are supposed to be 64-bit RAM, believe it or not. And once I can find a datasheet for these, we're going to have some fun with them. And I have a couple of them. I'll probably also do decapping on these. So yeah, more interesting early integrated circuit stuff to come still. I also found a source for some more circuit examples with the MAC198, and unfortunately it's in an early electronics magazine and there's no scans around. But I bought a physical copy and it's in the mail, so we'll just see. I probably will do a follow-up video on the MA245. Now the other meter's switching off. Anyway, I hope you enjoyed the video. I'll see you around.